Good morning. Welcome back to the DD Performance Research MR2 Squared project. You're staring at the back of our Project Spyder here. It's the morning of Monday, July 24th. Stage 1 of the project is just about complete. Friday we had our first start. We've got some the first startup video and then also a video of it idling posted on Facebook and on YouTube. And just going to do a quick overview of the car. It's going to be kind of a long one. I'm going to rehash some of the stuff I've gone over, but I figured this is a great chance to show you guys what everything looks like all assembled, and to cover the highlights again for those of people who are kind of joining us here later in the project. So what this is a 2GRFE. It's 3.5 liter V6 built motor. They are normally found in things like the Avalon, Sienna, Highlander, Camry, RAV4. Pretty big V6, naturally aspirated. We can get about 300 horsepower, 275 foot-pounds of torque out of them. Obviously, this one is no longer stock. You can already see it's got custom intake manifold and some powder coating and stuff going on. The internals are fully built. It has Dart and MID sleeves, Wiseco pistons. It has monkey wrench billet rods, ACL race bearings. It's got a upgraded valve train, springs, valves, also for monkey wrench. The expected power output on this thing is at least 500 on pump and 600 on E85. The turbo and everything else is capable of exceeding that by quite a lot. We're not sure how far we really want to push the motor and the drivetrain on this car. It should only be, as set up, maybe, we're going to weigh it, but we expect it's going to be about 2,500 to 2,550 pounds with everything all on the car. So 600 wheel on that amount of weight with a 265 tire is probably going to be a little bit of a handful. So we're not sure we're going to push any farther than that. But once we get on the dyno, we'll just see how she's doing, and we'll find out. Heads have been fully ported by us here at DD Performance Research, and we've also obviously microbalanced the rotating assembly and all that good stuff. The intake manifold's been fully ported. It is a custom upper intake, so the this lower plenum you can see right here, and the upper plenum. The lower plenum is CNC by us. The upper plenum is CNC as well. The flanges, I should say. The upper plenum box is a Holley EFI unit that we bought for an LS and then modified. The throttle body is a Hypertune. They're a company out of Australia. It's already CNC'd for the Wiggins flange, which is awesome. And it's also machined to accept a Supra or second gen MR2 turbo throttle position sensor, which is really cool. We do have a idle air control valve on the car, which is hidden down here behind the coolant reservoir. So start by going over the turbo system here. You've got a EFR 9180 twin scroll, capable of producing probably on this engine 900 to 1,000 wheel horsepower if we wanted to push the boost high on the 85 or race gas. You do have a very large K&N filter on the front of it there. Coming out of it, you see we have kind of a diverging system. There are two paths that it takes here. The path to the left goes to the electronic cutout, and the path to the right, and then from there that just goes down the side, comes out here straight to that tip. So it's literally just a straight pipe when the cutout is open. When the cutout's not open, it comes out through here, through the flex pipe. We've got a vibrant catalyst, high flow 3.5 inch catalyst, and then a Burns 3.5 inch stainless muffler, then loops back around and comes out that tip right there. Tucked down in here, you can see we have dual Turbo Smart 45 millimeter wastegates. The wastegates were given really good priority in the design of the exhaust. You can see that if you go back through our build videos from earlier. You can see over here there's some braided stainless steel lines. Those are actually feeding the wastegate air line. So we plumbed it in. It's got a 4-port MAC valve from Full Race, and we plumbed it in using Frigola AN lines. They're PTFE lines. The nice thing about them, they don't expand, they or contract with heat, they don't swell, they don't tend to melt, anything like that. And the one area where it is hot down there, you can see we actually got some of that DEI fire tube on there to help keep them cool as well. You can see there's a lot of heat shielding that's been employed here. That's what the gold foil and silver foil stuff is. We've also got a custom heat shield we built here to go in between the exhaust and the engine, try to keep the coils and wiring from melting or getting too hot. The turbo manifold there is, it's actually got a heat shield products, a very thick heat shield blanket on it, and then that's been wrapped with a second layer of DEI reflected gold thermal tape. And then the waffly looking silver stuff over here, that's also a heat shield products heat shield as well. That's a stainless steel overlayer with a fiberglass underlayment. Very good heat shielding product. And then the entire exhaust has been coated, including the turbine housing, has all been coated with the Polydyne ceramic coating. The gray is their titanium color, and then you can see that the tips are coated in a black. So let's see, going on to the intercooler setup. So we have obviously our Wiggins, the purple couplers here are our 8L Wiggins clamps. Really cool clamping system. And then you have our, it's a Garrett 1,000 wheel horsepower rated water to air core, custom tanks on it. We built it, obviously. The reservoir is actually integrated into it. It's in the back here. And then the feed from the reservoir goes right down to a very high flow Chapsco pump that's mounted in the front of the transmission. So it's a direct feed straight down from the reservoir to the inlet on the pump, and that allows the system to self-bleed. Very cool. We do that for all of our water to air systems. And then when it gets to the heat exchanger in the front, we feed water into the heat exchanger in the bottom, and it comes out on the top, and then it comes around and enters into the intercooler right here. So basically it's a very high flow system. We used -12 AN hoses to set it up, and the setup being like it is, it automatically self-purges. You never have any problems with airlock on these on that type of a setup. Let's see, other cool stuff. You've got your coolant overflow tank right here. That's actually the overflow hose from it. So if the coolant ever expands to the point where it needs to come out of here, it goes down through that hose, and that hose is wired all the way down to the bottom of the tranny. So instead of blowing coolant all over the engine, it'll just come out the bottom. And then this is actually your fill. So this is hooked up by a hose to the rest of the coolant system. That's your proper pressurized radiator cap right there. And then it goes down to the bottom of the reservoir tank on the front side. So that's really neat stuff. Our air intake, big Canyon filter. In our fuel system, we've got inside the car, you can't see them because they're covered, but we do have 320 liter per hour, Deutschwerks pump in the tank over there. It was with AN fittings coming out of it in a return line. That feeds the swirl pot. The swirl pot's got, or surge tank if you prefer. The surge tank is from Radium. It's got dual Walbro 460s in there. You can actually get as many as 3 in there, but this is more than enough, fuel for about 1,000 wheel. We don't need to go past that. So with all three pumps, you can get almost 1,500 wheel horsepower out of it on ethanol. So we've got Link engine management system. You can see over there that's a little communications box that's hooked up to the power management unit so that we can talk to it over the CAN circuit. That's the ECU Masters power management unit. That replaces all the relays and fuses that operate the engine. Really cool stuff. Worth Googling it if you haven't seen it. ECU Masters power management unit, or PMU. What it does is a lot of cool things. It performs all the switching functions. It's controlled by the EMS, and it also has data logging. It'll monitor current. It'll monitor peak loads and stuff. So you can actually log over time and see when like a pump or a fan is getting ready to die, because you'll start to see that the current load will change over time. It also lets us control and test things individually. So like when we were priming the fuel system, we were able to just turn the 3 pumps on from the PMU and run just the 3 pumps so we could prime the fuel system. Makes for really nice. Like if you want to do a compression test, we can actually shut off power. Like the injectors and coils are all powered through here as well. So we can shut off power to our injectors and shut off power to our coils while we're doing a compression test. So we can be certain that regardless of what's going on with the engine management unit, that the engine won't be spraying fuel or trying to spark while we're doing a compression test. So lots of neat functionality. Plus it's very compact. You wouldn't look at, but it's actually got I think 16 different circuits that it can power. So I mean, you're talking pretty large relay box that would be replaced by that very compact unit right there. It's all wired in. You can kind of see over here we did use mil-spec connectors for everything in the harness, and those are really neat. They're a twist lock, fully weather sealed design, and the other end of them you can't see in here, but they're buried up on the back side of the firewall. Coming back into the engine bay on the fuel system, you have a pulsation dampener right here. That's also a Radium product. What that does is all the pulsations from the fuel pumps and the injectors and whatnot, it's got a big spring-loaded accumulator that's in there, and it just absorbs those pressure fluctuations and helps ensures consistent pressure while the system is running. Then underneath, or on the back side of the plenum, you have another Radium product. That's a dual pump fuel pressure regulator. It's a very large capacity. You can see it's actually got 2 lines out, one to each of the fuel rails, and then it's got a big 8-8 AN line in and a -6 return. That's handling our fuel pressure adjustment for us. And then you have 2 Radium rails that you can't see underneath that intake manifold, and Injector Dynamics 1700cc stainless steel injectors. Yeah, so those are custom also for this project. Let's see what else. We got this radium surge tank right here. Dual surge tanks, one to each of the two different breather systems, one to the PCV, which has been gutted out, and then one to the regular breather system. Those are hooked up to the engine through AN lines as well, and then they have drains in the bottom of them. So I think that's pretty much it for the engine. There's probably some other, we do have a lot of sensors on there. So we've got a Pro-FI manifold pressure sensor, we've got fuel pressure sensor, we've got oil pressure sensor, we have manifold air temp. We also have post-turbo air temp, and we've got another air temp sensor right here in the air box. So we're actually monitoring air temps in 3 locations, and we're doing that for a reason. We're monitoring the ambient temps for basically some ignition control strategies. When the intake air temps in Dubai get very, very hot, we'll be able to run a slightly less aggressive ignition timing strategy, so that rather than having to respond to knock, the system will be responding on the feed forward side of things and running less aggressive timing so you don't have knock in the first place. And that's about it for the engine bay. I'm going to walk around to the car again real quick. We do have a logging dash right there, the MXG. We just pulled that off on Friday. It'll be going right back on today. But it's CAN enabled, and it does talk to the Link engine management system and pulls all the engine data on there. Also serves speedometer functions and logging functions as well. GPS enabled too, so really, really cool for track use. And then on the front of the car, you've got all the air suspension stuff. So you got pump, actuators, air tank, relocated battery. It's an Optima yellow top. We do have a couple of circuit breakers on there. These are actually pretty cool. So these circuit breakers are on both of the high voltage circuits. This one goes back to the engine, and then that one goes back to the, or I should say high current. That one goes back to the fuse box inside the car. And the neat thing is, if this, like, say the car ever runs over a concrete block and the wire gets shorted up against the body, it'll actually just trip this breaker. So rather than blowing a fuse or starting a fire, breaker trips, you can go under the car, correct the problem with the wire, just reach back up here, and you're right back on the road. So instead of leaving you stranded or catching on fire, it's just a minor inconvenience that you can easily deal with. That's the biggest Optima yellow top battery that's allowed with the Optima trays mounting tray. Very, very cool stuff. You can see the charcoal canister has been relocated down there, and underneath that is the engine management system, or the ride management system rather, from Ride Tech. These are all Ride Tech air suspension components. And lastly, we added a little fuse block over here for some of the additional stuff that we're adding in the front of the car. All right, that's it. That's the wrap up for now. We'll be making another video when we do some dyno testing, so we'll have some dyno videos up hopefully today or tomorrow. And then after that, we'll of course do some operational videos with driving the car. Thank you so much for joining us, and have a great day.